Dear technology friends, let me introduce Mr. Halidor Matsko from SEEK company with very special topic of today, which is renewable power sources for EV, charging and e-mobility opportunities and outlook. Heliodor is a successful and great enthusiast in terms of technologies, specifically in the field of charging stations for electricity vehicles and intelligent lighting poles. Let me ask you naughty questions. What car do you drive?
Well, of course, it is electric car. This is normal that the car is electric. However, I had to say that in front of your studio, there is no charging point. You need to think about it.
Oh, I will have to talk to the director or to the team, or maybe you can help us with this challenge.
I take your word for it, and let's discuss this afterwards.
Great, thank you.
Dear technology enthusiasts, let me introduce to you a topic of charging from lighting poles, because I believe that this is something that will play an important role in getting to net zero when it comes to carbon emissions. Before I talk about charging itself, I will talk a little bit about smart lighting, because this is connected with this. Did you know about the fact that 1/5 of global energy consumption comes from public lighting? This is quite a lot of energy. And with smart control of lighting, we usually save about 40% of this energy, which means this is indeed quite a lot of energy, and with today's prices, also a lot of money. So let me tell you how this works in reality. What is the smart lighting? First of all, we need to control each individual lamp. We tell each individual lamp when it should be on, when it should be off, and when it should be at what intensity. This is the most important part where we take the energy savings from. Second thing, we are providing remote diagnostics. That means if there is some problem with the lamp goes off or it's hit by the car or something, then we need to know and we report the fact before people complain or before some additional accident happens. On top of that, the lighting provides, of course, automatic mode, which means we are adjusting the lighting period precisely to the changing lengths of days and night. We are providing motion sensors. We are, of course, providing energy monitoring and reporting so that you know exactly how much energy you have spent and how much energy you have saved. And by the way, when we are talking about the public lighting is actually a great network because it is already installed everywhere where people live. And lighting poles are a great place to have additional Internet of Things sensors like meteo stations and carbon emission sensors and different kinds of tools that makes the city smart. How do we do this? We are manufacturing modules that we put into into each lamp and then into electrical cabinet. And this provides us with the communication method, how to talk to each individual lamp to tell it what should be the intensity, what is the current condition of the lamp, etc. But the most important part about this is that if you run a simple calculation, that when you are thinking about changing your lighting from old sodium yellowish light into much more effective LED light, and you calculate your return on investment, you will find that when doing this, of course, making the public lighting installation smart and controllable does add to an investment cost. However, it brings additional savings, and these additional savings allow it to have return on investment much faster than if you did it. So it always makes sense in the city. If you are switching the lighting into LED, you need to do it smart immediately, and then you save much more money. How does it work technically? Of course, this is not something that we would invent itself. The lighting control idea is not very new, and there are different approaches how this can be done. One, maybe the oldest approach is to simply stick a SIM card into each lamp, which will allow each lamp to communicate, and this is the communication method that allows us to do the smart lighting, which works. It's fine. The only problem is that the cost of communication for each lamp actually costs so much money that your savings, what you save on energy, you are actually paying for the communication and for the equipment. So this is not exactly the best type of thinking about saving. A little bit newer approach is to use radio mesh networks, which are based on Wi-Fi or Bluetooth or different protocols. And basically this works so that if you have lights, street lamps on the street, then the first light sends the command to the second light, that sends the command to the third light, to the fourth light, etc., etc. And all these lights are in clusters, and they are exchanging radio data packages. And this lives in a sort of big radio network where everybody talks to everybody. It is a little bit messy, and the main problem, this is also working and it's fine. The only problem is that every time when there is a new building or a new tree grows larger, and we are losing the communication between two lamps, then the system needs to find a way around that. However, as long as our streets are usually linear, we have a problem and we lose the communication, and this is happening pretty frequently, that somebody needs to go and add additional antenna somewhere and solve it. We at Seek are using different approach. We have developed Internet of Things communication protocol for power line, which means we are communicating with the lamps over the same wires that deliver 230 volt to the lighting, which means as long as we have power, we can communicate, and we need no antennas, and we need no complicated mesh protocols. And it is pretty stable. As this communication type has been invented especially for lighting control, this is a low-frequency power line communication method, and it is patented, and it allows us to communicate over 5 kilometer distance between the electrical cabinet and the last lighting point. In Europe, the largest power line for public lighting that I have seen was about 3 kilometers, so we are good to go for practically every type of the electrical grid. And also, as this type of communication is low frequency, it is extremely stable, which means we do not really care if there are trucks or trams going along the way. This does not affect us really. Now a little bit about the electrical cars. Electric cars are very cool, and if you try to drive electric car, there is a big chance that you only are thinking, where am I going to charge my next car? Because you are already sure that your next car is going to be electric. This is how it works, and this is what worked for me. I made so far something over 300 kilometers already electric. However, when you get home with your new electric car and you don't have your own garage with your own charging point, you need to think about where do I charge my car? It is not exactly practical to go every other day into a shopping mall to plug your car. So it is very important that if you are parking your car on the street, that you have a place where you can charge the car. And not by having the cable from your window somehow to the street, because that's not maybe the best idea. So we had decided that we are going to combine these things, and we have integrated these two technologies, and we have developed a charging station which is integrated into the lighting pole, which is using this patented low-frequency power line communication to talk to the central system, which is also managing the grid. And this allows us to convert practically every lamp pole on the street into a charging station. How does it work technically? As these charging points are not isolated but are communicating over the power line with the lighting system, during the daytime when the lights are off, all the capacity, electrical capacity that we have on the street is used for the cars. So in this particular example, if we have 30 kilowatt capacity and we have two cars charging, then they are sharing this capacity based on the needs and capabilities of the cars. Not all cars can use full capacity for the charging. There are differences between different types of cars. In the night, if we have smart LED lighting, then let's say we would be using 5 kilowatt out of this capacity for the lighting, and the remaining 25 would be again split in between the cars that are charging. I have here a little animation that shows how this works in reality. So imagine we have a street and it's daytime and the first red car comes and it basically gets all the capacity for charging. When the green car comes, the capacity is changed and they split the charging current. And when the night comes, all the cars and the lighting are sharing the full capacity. When the red car, because that was the first one, is charged up, then it waits and we are splitting the remaining capacity again with the cars. And when the light is dimmed, for example, after midnight, again, we are using this capacity for the cars. Whatever is happening over the night with the system, automatically, the most important thing is that in the morning, all the cars are charged up. And this is what we call load balancing between lighting and charging of the cars. And this allows us to provide charging stations practically on every street. Now, the technology is here, and we have implemented it already on several places. And let me share with you some thoughts, what to keep in mind when thinking about this kind of charging. So first of all, you need to have parking places which are next to the lighting pole. Sometimes this is not the case, sometimes this is the case. If the lighting pole is next to the parking places, of course the best is if the cars are parking perpendicular to the sidewalk. because then we can reach with charging cable to many more places for the cars. And typically the charging cable that every electric car has is 5 or 6 meters. So in this case, we do not need to have the charging place reserved only for electric cars, which of course would, on the congested places, would not be the best thing to do. Second thing is we can convert the old lamp pole by providing a special type of wall box which will be hooked on the old pole. Or if this is a new installation, for example, we can provide a brand new pole with all the electronics integrated already into the pole. It looks nicer. It looks and it is also vandal resistant. I often get the question about the capacity because, of course, this is not a super fast charger, because for super fast chargers we would need to have special transformers and much capacity. This is type of charging which is where we expect the car to be parked there on the place for several hours, and for convenient charging of the cars, 11 kilowatt is today the best option. However, it still makes sense even if it is 5 kilowatt. And here in this table we have different types of electrical wiring which is used in European cities. And as long as we have, for example, copper 6 millimeters square cable, then typical capacity which is available is over 40 kilowatt that we can share between the lighting and the charging, which allows us to have on that street 4 chargers with 11 kilowatt each, or 8 chargers where they will share the capacity dynamically, because we do not expect that 8 cars will come all at the same time. And if it does, then they still get 5 kilowatt, which is good enough for the car to be charged in the morning. One important thing about why this has to be linked with the smart lighting. Well, because if you don't have smart lighting, then during the daytime there is no energy in the lighting pole because the power is cut off. But we want the chargers to be operating 24/7, so we need to make sure that there is power 24/7, and during the daytime the lights are off at the same time. We can do that, of course, even without changing the lighting by providing power line modules with relays that we install into the light, and that allows us to have during the day the light off while the power is still on and the charging stations are operational. Now, another question that I typically get is, well, and are you then going to give away this energy for free? This is not fair. Of course, this is not fair, and this would not be sustainable, because with the growing number of electric cars, there will be also growing demand of energy. For your information, in this type of charging, a full tank or full battery of the car, the cost of this energy is somewhere between 4 to 7 euros in today's prices. And so it is not a huge amount of money, definitely not compared to the gasoline cars. However, For this to be sustainable in the long term, we need to charge money for the energy. And we are providing a software system for the municipalities that want to implement this kind of system. We collect payments from the people for the charging, and by the end of the month, we are providing this type of report to the municipality where we show all the charging sessions that happened during the month, when it was, how much energy we have consumed, how much money we have collected, and after deducting our commission, we are then submitting or remitting this money to the municipality to cover the energy cost. So that this is the way how the municipality can provide cheap on-street charging possibility for EV car drivers at very low cost. And what does it mean for the electric car driver? I come to the lamp pole, I plug my car in, I open an app on my mobile phone, or I scan QR code, which is on the sticker on the lamp. I log in and I press the start button to start the charging, and this is all. So after finishing the charging, the respective amount is taken down from my credit card, and I receive an invoice for my charging into my email box automatically. That's all. We are trying to make this very simple, or as simple as possible, for the drivers and also for the municipalities. And yes, we are manufacturing all of these electronics here locally in Prešov in Slovakia. And so this is indeed European made. And thank you very much for your attention, and I hope that your next car is indeed going to be electric and you will have place where to charge it. Thank you.